My name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. Now let's get to the show.
Morning. This is quite an event, huh? It's quite a venue. My name is Alex Williams. I'm a founder and editor-in-chief at the New Stack. And I just want to welcome you to pancake breakfast here. Thank you very much for coming by. I want to first thank, before we really do anything, I want to thank our sponsors, in particular CloudSoft and Apcera. And I recommend checking out the way CloudSoft is doing, what they're doing with Apache Brooklyn and Clockcroft, which they describe as the Docker Cloud Maker. I'd also like to thank Apcera, which has developed what they call a hybrid cloud operating system, which takes a policy-first approach and delivers an order of magnitude increase in freedom, security, and speed across any IT infrastructure. And David will talk about that, and things we get going. I'd like to introduce our panelists here. David, why don't you just introduce yourself?
Hi, my name is David Blank-Edelman, and I'm the technical evangelist for Apcera.
Adrian, Cockcroft. I'm work at Battery Ventures.
Kelsey Hightower, CoreOS. Owens at Cisco.
Great. I was thinking about this talk here, and what we discussed with the panelists and everyone here, and the New Stack is more symbolic, or as a way to understand app development and management at scale. We consider this kind of core to what we write about. In particular, how it runs across fast, sophisticated and distributed infrastructure. The question is, what does the New Stack really represent? And what increasingly that seems like it's more of a resource than anything else. And that resource is going to spin up services that can be managed programmatically, which brings us, in many respects, why we're here today in this very interesting venue. So this is quite a venue, isn't it? It has a sense of like a warehouse, almost like a machine itself. You can look at the art on the side here, and kind of feel like you're in the machine to some degree. But before I really get into things, I wanted to really thank the folks at Container Solutions. And thanks in particular to James Dobson, CEO of Container Solutions, who made it possible for us to do this pancake breakfast here in Amsterdam. So, really, this is really quite an interesting time for this conference. Programmatic infrastructure is represented in the big internet scale companies and public services such as AWS and Google. But now we're really seeing the availability of services and software that offer companies ways to keep their balance of legacy infrastructure, but also build out new services. And I think this is really represented by the symbolic rise of Docker and the subsequent interest we're seeing in container orchestration and the rise in popularity of things such as microservices. So here's really what I'm hoping we can get out of the breakfast this morning, out of the podcast this morning. Really, as we all go through the next 2 to 3 days, my thought was to talk about the big questions we have. So it seems like such a good time to do that because there's been enough kind of discussion already, and people are actually starting to use the technologies, and so these concepts are now moving actually into practice. There's a body of knowledge out there that we can think through to form these questions, and then discuss the relevance of the discussions we hear today and tomorrow. So that's really the theme that I'm trying to develop here, is what are some of those big questions that we might be wanting to think about as we listen to people talk, as we have conversations with each other through these next 2 days. So the interesting thing is that, I think it kind of hits the heart of this idea of programmable infrastructure is applications on infrastructure becoming the heart of the data center. Or the question is, is that really true? If it's not true, how does this jive with the concept of programmable infrastructure itself? And so that leads to all kinds of questions about the OS, the state of virtualization, app development and management at scale, all these kinds of things. Before we get started, I'd like to get a sense about who we have here in the crowd. So how many people here would consider themselves a developer? Great, wow. In operations? Okay, it's a kind of combo. Who does development and operations? They all do. There we go. So I'm going to be coming out. I'm going to think if you guys can think of questions that you would like to ask. I think it'd be good to get your guys' perspectives on the kind of things that you're experiencing out there. What you're trying to get out of this conference as you think about this whole idea of programmable infrastructure. And I thought we would just get started with Adrian. And the question I have is, really, what are some of these big questions that you're thinking about? In your studies of programmable infrastructure itself, you've been really practicing longer, for quite a while. You've recently been talking about this whole idea of rugged systems and services. I'm curious about that. So really, I'm curious, what do these new kind of concepts mean to you right now? In terms of that idea of rugged, what brought you to that concept? Maybe you can explain it a little bit.
Sure. If you look back over the last few years, you see that developers have been driving the development. So developer-driven infrastructure is another way of looking at it. If developers get more control over the pipeline they use for getting stuff out. So you end up owning how fast it takes to do things in the development, the production pipeline. And DevOps comes from that where, okay, if you click a button and put it in production, or your tool chain puts things in production, the developers own what's in production. So they own how fast it gets there, but they also own how efficiently it gets there. So they don't just own the sort of agile with a small A, not getting into big capital A agile, but the sort of how agile they are, they own how lean they are. And then once you're on call, if you get a security break, alert, you're on call for that too. So you're on call for how secure it is. And that's one term for that we've been using is rugged. So that means that developers are now concerned with how quickly they do things, how efficiently they do things, and how securely they do things. And they need platforms that can express those up to them. So they need help, they need systems that they're working with, and it should be API-driven platforms. But it really comes down to owning these new things and trying to understand what it means to build secure software from scratch, so that you don't get woken up at 3 a.m. by being breached. Like you don't get woken up at 3 a.m. when a machine does.
David, what are some of the questions you're thinking about when you're thinking about what Adrian is saying here about the need for, this A with lowercase a, is that what we're saying here? And this whole idea of this developer-driven infrastructure that we have. And we've been hearing about kind of, the rise of the developer communities. I'm just curious how you see that in line with this whole idea of programmable infrastructure and what that means for you, and what you're thinking about, what questions that's leading to.
So there are a lot of questions in there. Let me see if I can tease them out in order.
Great.
I think what Adrian says is absolutely spot on, but I think that having to have all these different hats put on a developer who's never had to necessarily think as far into these separate fields gets really difficult. So I think that the more the platform can do to make it easier for developers to be the security person they need to be the reliability person, to have the instrumentation they need, the better. And to my mind, if you can come up with a platform that is sort of secure by default, or you have to work harder to make it insecure, that's a fine thing. Work with the people to make it with their natural inclinations, is my sense. In terms of what I think from a programmable infrastructure perspective, I think that in order to have that work out well, you have to set up some sort of structure within that allows the people to set up what they need to make things as secure as possible to start, and then they can pay attention to the other stuff. In the way we deal with it at Apcera is we think about things from a policy first perspective. If you can set up a set of policies that say, here's what you're allowed to do, here's what you're not allowed to do, or it's not okay to ever deploy a Docker image to production that has the following CVE security alerts in it, then our thinking is that developers can spend their time, once they've got some of the secure stuff done, nailed down, doing what they do, which is they're writing software not because they want to make things, not because they're producing security as their end product, but they're producing code, they're producing stuff that does stuff. And so we think it's really important to be able to give them sort of guardrails. Once you set the guardrails up, and then it goes faster than you want.
Kelsey, are those guardrails that you needed? And actually, I'm interested particularly your thoughts about the OS, and especially since CoreOS is involved there.
Yeah, so I think when we talk about programmable infrastructure, right, so I was a sysadmin in the majority of my career, and maybe the last 5 or 6 have been full-time development. So I think it's always been programmable, but the interfaces were terrible, right? Like the switch vendor, you've been stitching together things that were not designed really to work together other than plug into the right socket. And the language we've been given to deal with that was like Perl and Bash. So it was very raw. There was no standard library. You just kind of mixed SSH, and you did kind of program these things, right, via shell script. And I think what we're seeing now is that their standard library is much better. We call that standard library AWS, GCE, Apcera. CoreOS gives you kind of some tools to deal with that. Docker does as well. So I think now that we have a much better standard library, we actually can move to a better programming. So you no longer have to use Bash for everything. So now that you have something that actually programmable is, that's not just raw hardware or the command line utility that we've been writing all this time, we actually have a set of APIs. So I think now when we talk about the OS, for instance, we can remove all those things. So there's no Perl in CoreOS, right? You still have a shell that's going to be able to walk around. But we assume at this point, all the software that you need to program or the infrastructure to program actually has an API. So I think that's kind of where we are at this point.
And your thoughts on the network and the infrastructure. Cisco's traditionally been a hardware company. Really starting to think more about software, as to how it applies to your own business. I'm curious why, and as you go on this journey, what are these thought processes you're going through, some of the questions that you're having, and how it relates to this whole concept of programmable infrastructure?
Yeah, I think that's really the interesting part of this whole discussion is it gets more complicated every year for developers to do what they want to do, which is write code and help the business make money, right? And so what I think about the most in this space is when you look at that infrastructure, what Kelsey said is absolutely right. It's been very difficult to programmatically define an environment to build your applications on top of, because you have to understand the network pieces, you have to understand the storage pieces, you have to understand the virtualization environment to some extent, because if you avoid loss security, then the VNet and some of the components of that underlying virtualization will become very critical to securing the application. And so making a kind of a standard abstraction layer that the developer doesn't have to worry about the underlying infrastructure. So I'm a big fan of APIs. I think APIs are great. But I think APIs are for like our grandmothers, right? They're kind of for the people that...
APIs are for your grandmothers?
For your grandmothers, right? They're kind of old, right? That's what people did 5 years ago, right? I think now you need services. You want to have access to quick services. You need a network service. You need a storage service. Why define a bunch of APIs that require developers to figure out what neutron changes have happened or what NSX changes have happened in the last few weeks? Like, why? Who gives a fuck? Let's just write the code, put the code out there, make money on it. If the network is broken, call me. We'll fix it, right? That's what we do. If you have a problem with the infrastructure, call the infrastructure provider and say, hey, fix this infrastructure, it's bad, right? You shouldn't have to be dealing with underlying infrastructure programmability problems because it should just work. You should just write your code and push it out.
So, Kelsey.
So the rebuttal is the API is going to break us from the vendors. So the lack of APIs is what got us locked in the first place. The fact that you cannot program your switch is why you're waiting for SDN. Now, when a vendor says, here's all the APIs, I'm not going to hide anything from you, whether that's an NXOS, a new vendor comes in town, you no longer wait for that vendor to tell you what the next path is. So if you're AWS, you're free to make the network be whatever you want. And the end user, when you say an API, once you have an API, then you put a dashboard on top. You can hook it up to a knob and make it twist it. But the thing you cannot rely on is not having the ability to change what the knob looks like. Because if you can't, now you're stuck. And then that knob becomes old, you just have to deal with it.
You gotta limit that knob. David?
Yeah, I'd like to pile on if I can. And I say this with a great deal of affection, having typed in many pieces of Cisco equipment over the years. To my mind, what an API represents is an abstraction. It's the way of how we decide what are the objects in the system, what are the things we're going to be interacting with, even if they're not used. And I wish my grandmother had an API, for her knitting or whatever. But I think that's the key thing. That's why I think the value of even if every individual is not going to interact with the API, means that the vendor has been forced to provide a cohesive, cogent abstraction for what we're talking about when we're interacting with whatever it is they're providing. And I think there's incredible value to forcing people to go through that exercise.
The only thing I add on is the issue I have with API is that they give you the same lock-in problem. You're tied to that API, and the next release of the API, there's always changes to APIs.
Who here has issues with APIs? Oh, okay. Can you tell me what your issues are? And how you're...
Also, they work at Cisco.
I'm curious what your questions are as well, what you're thinking about as you come into this conference.
Yeah, it's too fast. I have interest in APIs. I don't have a question at the moment, but yeah. So when you have APIs, you can build your own services on top of that. So as a software developer, I like APIs because it's easier to use the infrastructure. On the other side, I can provide my customers, easier interface. So it's maybe for customers it's not such important APIs, but for me as a developer it's quite important. So that's why I like APIs.
Anyone else want to give their thoughts? Oh, right. All right, Daniel.
It's very interesting, and I was thinking that with Mantle coming out, obviously the success of Mantle was sort of predicated on APIs from other things, such as Mesos, etc. So,
I'm not saying we shouldn't have APIs, I'm just saying developers should have to think about those APIs. There should be a services layer between the application code and those APIs. Everything should have an API, just to be clear. But I don't think a developer needs to have to think about the API.
There are too many standards, so we need to add a new one.
I definitely
is even more standard, so you've got another layer of API.
I would rather have a standard though than have a CoreOS Docker file. I mean, we're just adding complexity on top of what's already a complex environment to write APIs against.
I think there's two different things here. One is that in the modern world there are too many APIs to understand. I recently spent 2 days trying to figure out how to parse YAML code with code. After the 2 days, I found the 3 lines of code that did it, but I just hadn't done that before. I was trying to figure out how to do it. So in the end, I codified it in 2 or 3 lines of code, but you have to go find out all of the different things and which YAML library you use, and I'm hunkering around to get up and trying to understand things. So you get stuck in that kind of loop. But so the one thing is there's just too many of them. And if you look in particular at AWS, they're adding whatever 1,000 new features a year or whatever it is. And they've got many years of doing that, so it's just so much stuff. So now you have to be an AWS certified engineer, like you have to be a Cisco certified engineer or VMware certified engineer, which means if you're into training classes, you should at least know where to find out about all these APIs. So that's one problem, is there's too much stuff. And the things you have to know are becoming bigger and bigger. But that's separate from whether they change. And, I don't know, AWS hasn't retired any APIs that I can think of. They all kind of still work. They don't stop. And there's new APIs, but they're not changing the options. And so having APIs that are stable over a long time lets you build things that still work in the future. So separate those two.
Can I just follow on? So, with the layer of services again, were you thinking all the API or the interface would be there to them? Would it be sort of REST-like?
So you mentioned Mantle. There's another piece of Mantle that's called Shift. And Shift is more of just a web interface. It's in-get. It's very easy to use. It's shift.cisco.com. And the idea with that is you just download the code using Vega. So console. We're using tools that every developer is already. We don't need to create a new tool or a new standard, right? We just need to put together the tools that exist in an easy tool chain that allows a developer to write their code, do a git push, select where they want to deploy it to, deploy their code there, and then manage it and run it continuously from that point. That's what developers want. They don't want to have to go in and figure out all the 25 different interfaces they need to touch. Go configure them. Spend days learning about them. Every company thinks about their API strategy now. Like many years ago, no one had an API strategy, right? But now everyone's thinking about how do we manage these APIs today and in the future, and changes to these APIs over time. Because as you mentioned, every new feature has a new API interface. You have to try to understand how to extend your code to take that new interface. So to me, it's more about, I think more about freeing the developer to write code, deploy that code anywhere they want, and then run it from that point on. And think about it from the security, the interfaces for the network, they connect all those different environments together, and just not have to think about not have to be focused. They can, right? I don't want to hide interfaces from anyone, right? So that if you're a developer that likes to get into Neutron, or get into NXX, or get into AWS APIs and write directly to those APIs, go for it, right? There's nothing wrong with that. Just do what you need to do. But I don't think you should be forced to do that every single time.
So Kelsey, and then a question here, and then David, I'd like to get your perspective about complexity.
Yeah, so I think when we say APIs and then the interface that you expose on top of those APIs, I think it's the workflow thing that drives the ability to mix multiple things. So the thing that you guys talked about building was only possible because all the tools you just named had APIs. And you're going to get people to a new checkpoint to where the workflow that you deliver them will always want to be customized a little bit further, mainly because you have to work with maybe multiple things. So this one item and this other item, which means you're going to probably introduce a new workflow at some point. And one of those things that causes friction is no API will be the thing that will be removed from the workflow because it's no longer automatable in the entire flow. So API is a standard requirement, but it's not necessarily where you stop. So it's the API versus the Amazon dashboard. Not everyone wants to click around.
Yeah, hi. I'm a little puzzled as to what you mean by APIs when you say that we don't need them anymore. Because as a developer, all I do is use APIs, application programming interfaces. If you say you need to layer a service on top of those APIs, how am I going to communicate with that service? It's going to be via the services API, essentially. So what do you mean when we say what is your definition of API when we say we don't need them? And the second thing is, as a developer, an API represents a promise by a vendor to me that things will behave a certain way. And that's really valuable because that allows the vendor to iterate on the implementation and still give me predictable results. So how would you keep that promise, so to speak, if you get rid of the construct API?
So I would never get rid of the API construct, because I mentioned I still allow it, and we do still have that API there, even as we go through the making. Mantle and Ship both have APIs, right? So the concept of the API is important, and I would never say we get rid of it, but my point is more, I give you the service construct, I SLA that service. At that point, you now have services that you're getting SLAs for. Those services are not dependent on the underlying APIs that we are supporting and managing on behalf of your service.
I think high-level abstractions is really what you're saying. Right? So going from low-level APIs, maybe libraries and things like that, to service level.
Well, David, I would actually ask a question. This really relates to this whole issue around complexity. Right? What are your thoughts about this whole issue around these very complex systems that we're starting to see emerge with programmable infrastructure? We're having this kind of whole back and forth about APIs. Right? And APIs have been a really kind of a core part of the discussion for several years. And it seems to me what Ken is saying is that there needs to be almost like there should be having to think, which to me leads to these questions about the complexity itself of these systems and how you're going to continue to be able to mitigate those types of issues.
So humans do a number of things to try to deal with complexity. They do things like hierarchy. They put things in hierarchies, and so that you don't have to actually do things at the very lowest level. And sometimes they put abstractions in front of it. I think that sometimes they put stories and narratives around things to be able to relate multivariate things to people. So if I'm going to tell you a story, I can give you a fairly complex set of things. Let's say you're going to talk about an outage or a downtime. I could tell you a story about an outage that I had at a previous employer. because we don't have outages in Apcera. And we would have a long discussion, and it would be fairly complex stuff, but I'd be able to work it into that sort of stuff. So I think that what we're searching for here, and sort of what we're searching for at the conference, is ways to talk to each other about this complexity, where we can make sure that we're talking the same language. I mean, part of the complexity that's being talked about on stage has to do with the fact that there's the AWS API, there's the GCP API, there's the Tectonic API, there's the Kubernetes, from these sorts of things. And so the question is, how do you avoid drowning in quantity? Can we start talking about this, as we suggested, at a slightly higher level, such that we can say, oh, well, we all understand what a load balancer is. Let's talk about it in one way.
I'm going to get a question from Duncan and then Adrian.
Yeah, I wanted to explore this notion of intent-based. So moving up as you say, so you're not dealing with APIs or in some respects even thinking too much about the services. So the notion, particularly in networking, for example, is so complex that I much prefer, if I'm coming at this from an applications point of view, to just state my intentions. What do I need? It's like a Venn diagram of the connectivity versus getting into the weeds. It seems to me that's what you're driving at.
I think there's a couple of different approaches here. You've got a relatively sophisticated architecture and you have these intent-based things. Sometimes the intents look simple, but you have to understand a lot more about what actually happens, right? You end up looking underneath to try and debug it and figure out what's going on. So there's the kind of top-down, very architectured approach. A lot of platforms have very opinionated platforms. You're kind of buying into that architecture. It works well as long as it's the right thing for the right build. So you have a lot of different platforms aimed at solving different classes of problems. The other way is bottom up, where things are more composable and sort of a little bit more. It does one thing easily. And I want to bring up Martin Nikos, who has his 15-minute rule for open source projects. If in 15 minutes you can download it and it does something useful for you, then that project will become viral. And that's, he was talking about MySQL when he first sort of talked about that. Why did MySQL take up? Because it was easy, you could use it, and everyone did that. And then we've seen that again with Docker, where it just went, okay, yeah, that solved the problem, I can move on to my other problems, because this piece has been solved. We've seen it with a lot of pieces of the Docker ecosystem. We, in particular, are very easy to use, so lots of people use it. Now, okay, my next problem is something harder, right? So people are bringing in pieces that are easy to understand conceptually. There's an easy onboarding, they just work. You didn't have to go sign $1 million license with an enterprise vendor to try it out. So there's a whole bunch of places where the friction gets taken out. And then we can close out of these sort of bottom-up pieces. So I think there's a sort of a tension between building stuff up in the bottom and having this, and then you're going to say, maybe a net of little things that all work individually, or do you want to have this top-down sort of overall architecture thing where maybe you're writing policies and the policies are somehow turning into code sort of way down in the system?
So we now only have a few minutes left. I was wondering if anyone would like to ask a question.
Hi, I'm Claudia. I wanted to ask, as a developer, when I develop APIs, my biggest problem is often backwards compatibility. And I was wondering in that situation, because I always have a problem that you have to kind of update all the services to use the latest version and get rid of the old code and so on. So how do you view that in an infrastructure API?
Kelsey or Ken?
I will start really quick. I think in the infrastructure world, it's a little easier because the thing that we abstracted is well defined. Like there's only so many file systems and only so many ways to format it. So the API you present has to change usually at that pace, unless there's of course bugs in it. So the thing that we're wrapping is kind of well defined, which kind of gives us a little bit of a way of achieving.
And then just to add to it, I think the other piece of that is when you have a new technology or a major change in the product line, those APIs still have to support existing capabilities. And so, I know most what I would say is make sure your vendors are supporting backwards compatibility as they move the products forward. Because you don't want to have a situation like Cisco where you have like iOS and XOS, right? You kind of have two different streams of OS. You can just understand why they had to make that move, but it was a very painful move for customers, right?
David, want to conclude with you?
I was just going to say, one of the talks that had me for a long time is I think that one of the things we don't do a good job when it comes to infrastructure and APIs is building APIs and infrastructure that's meant to be demolished. When you build a building, you often build a building with some notion about how you're going to take it apart when it's done. And I don't think we do a good job of that now in what we're building. We don't think towards that. And I think that because we all know we're going to be deprecating something at some point, we should really have that as one of the things that goes into that this planning process.
So this idea of deconstruction.
Deconstruction, I think of that in the art world.
I'm curious. It seems like we're kind of in a place where you could celebrate the deconstruction.
Well, I mean, yeah, absolutely.
Well, great. Well, I want to thank you guys for participating in this pancake breakfast this morning. Thank you all for being here and enjoying the pancakes, and let's enjoy the conference.
That's it for this week's show. Thank you very much for joining us. Audio editing and sound design for the new Stack Analysts podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.